Lecture we are going to study about the solar radiation. Okay, the solar radiation is the radiation which we receive from the sun. Now we know that in our solar system we have a star, and the name of that star is sun. Now we receive the energy from the sun in the form of the solar radiation, okay, the light which is emitted by the sun. Now this solar radiation which is reaching to earth, we can call it as the incoming solar radiation, okay, and in short we can also call it as insolation, which means the incoming solar radiation, okay, insolation. Now the insolation, that is the incoming solar radiation, that is not evenly distributed on earth, okay, it is very uneven distribution of the solar radiation on earth. Now there are various factors behind this uneven distribution of solar radiation. इसके पीछे बहुत सारे कारण हैं, ठीक है. Now we are going to study about these reasons in a detail. So first you will find that the tilted axis of the earth is mainly responsible for this uneven distribution of the solar radiation on the earth. Here you can see, and in our previous lessons also we have studied that the axis of the earth is tilted, okay, the axis of the earth is tilted, and the sun rays which are falling on the earth, they make various angles, okay, when they reach earth they form various angles. So the largest angle they will form here in this case is at the Tropic of Cancer. They are completely perpendicular to the earth surface, okay. So here they are making nearly 90 degrees angle. So in this case the Tropic of Cancer will have the more insolation, okay, that means the Tropic of Cancer will receive the more solar radiation and it will receive the more energy. But as we go away from the Tropic of Cancer, okay, at the equator it is making the angle of 66.5 degrees. Now this angle is made by the sun rays which are falling on the surface of the earth, okay. जो सन रेज अर्थ के सरफेस पर आ रही है वो एक एंगल बना रही है, ठीक है, और ये एंगल है 66.5 डिग्रीज एट इक्वेटर. ट्रॉपिक ऑफ कैंसर पर हमने देखा इट इज फॉर्मिंग अराउंड 90 डिग्रीज एंगल, ओके, डायरेक्टली परपेंडिकुलर है टू दी surface of the earth. That means these areas are receiving more energy, okay, these areas are receiving more energy, and as you know the earth is rotating around its own axis also, okay, from west to east. The earth is rotating around its own axis from west to east. तो ये जो डायरेक्शन है, this area when earth is rotating, so this area will also have more number of insolation when this will face the sun rays, okay. Here because you can see this is the night, when here will be day, and this area will also receive the same amount of energy where in this part is also received, okay. So this area and this area will receive equal amount of energy when the earth is rotating around its own axis. But in the other cases, if you see in the north pole and the south pole, here you will find the difference of the distribution of energy. Now in this case, north pole will receive more amount of energy as compared to the south pole. Why? Because here we see that the Tropic of Capricorn, the sun rays are making an angle of around 23.5 degrees near the north pole, okay. 23 and half degrees. The sun rays are making around 23 and half degrees of the angle near the north pole, but at the south pole it is around 0 degree. So you can say that nearly there are no sun rays falling at the south pole. So here in this case the north pole will receive more amount of energy. But we know that this is not a permanent case. Why? Because we know that earth is revolving around the sun. Okay, so now here you can see this. So after some time the earth will be on the east side of the sun, that is sun will be somewhere here. Okay, sun will be somewhere here, and at that time the sun rays will falling in the will be fall in this direction. Okay, so in this case the south pole will receive more amount of energy. Okay, in this case, and north pole will receive less. Why? Because in this case the angle which will be made by the sun rays will be less, and here the angle will be more. Okay, so it totally depends upon the rotation of the earth as well as a revolution of the earth. Earth is rotating, and secondly the earth is revolving around the sun, and that determines the distribution of the solar radiation on the earth's surface. Okay, so these are the two important things: rotation of the earth and revolution of the earth around the sun. Now the position of the earth near the sun also determines the incoming solar radiation. How? You should remember that the earth is revolving in an elliptical orbit. For example, you may consider that this is a sun and this is the elliptical orbit of the earth. Okay, we will draw a new diagram. So for example, you may consider this is the sun and this is the elliptical orbit of earth. Now for example, if sun, this is the position of earth, and you should know that, as we have studied in our earlier lessons, that earth is revolving around the sun. So this is the elliptical orbit of earth. Okay, earth is revolving in this manner. Now this is the farthest position of the earth from the sun, and in this case earth will receive less energy, but there will be a time when earth will be closest to the sun, that is it will be here. Okay, so at this time earth will receive a more amount of energy. Now this is called as aphelion or perihelion. Okay, so the position where earth is closest to the sun, is called as perihelion, and when the earth is farthest from the sun, it is called as aphelion. Okay, perihelion is the position of earth when it is closest to the sun, and aphelion is the position of earth around the sun when it is the farthest from the sun, and it also determines the incoming solar radiation. So in the aphelion, when earth is farthest from the sun, the incoming solar radiation will be less, but when earth is closest to the sun, that is the perihelion, at that time the incoming solar radiation will be high. Okay, so these are the some of the important factors which determine the incoming solar radiation. Okay, that is the rotation of the earth around its own axis, then revolution of the earth around the sun, the position of the sun, the position of the earth, and secondly the farthest and the nearest position of the earth from the sun. Okay, so these are the three important factors. Now the incoming solar radiation is received in the atmosphere, but you should know something which is very important, and that is the heating and cooling of atmosphere. And how does this happen? Now we have known that the incoming solar radiation, that is the insolation, is coming towards the earth, and earth is receiving energy from the sun. But how does this atmosphere get heated up? Now in our previous lesson we have studied that atmospheric air is mainly transparent to the solar radiation, mainly. Okay, it can absorb some part of it, but mainly it is transparent to the incoming solar radiation, the solar radiation which is coming from the sun. Okay, and here you will find the atmosphere is mainly transparent and it can pass through. Okay, and it can reach the earth's surface. This is, for example, you consider this is the earth's surface, and the solar radiation, that is the insolation, will fall down. So by this the atmosphere doesn't get heated up. Remember one thing, by the insolation the atmosphere does not get heated. Insolation doesn't heat atmosphere. Now you may say that then how does this atmosphere get heated up? ओके आप कह सकते हैं सर अगर इंसोलेशन से अगर एटमॉस्फेयर हीट नहीं हो रहा है, अगर एटमॉस्फेयर का टेम्परेचर इंसोलेशन की वजह से नहीं बढ़ रहा है, तो एटमॉस्फेयर का टेम्परेचर कैसे बढ़ रहा है फिर? ओके, सो द सिंपल आंसर इज द एटमॉस्फेयर गेट्स हीटेड अप ड्यू टू द टेरेस्ट्रियल रेडिएशन. ओके, terrestrial radiation, that is the radiation which is radiated by the earth surface from the terrestrial radiation. So this is the earth surface. Okay, and it is absorbing the insolation, and after some time it will radiate it out. Okay, so this is called as terrestrial radiation. Okay, so this is the terrestrial radiation. So the main thing behind this is the radiation which is radiated by the sun is of short wavelength. Okay, and the radiation which is radiated by the earth, that is the terrestrial radiation, it is of the long wavelength. Now this makes the difference. Now the radiation which is radiated by the sun, it is in the short wavelength, and the terrestrial radiation, it is in the long wavelength, and atmosphere cannot absorb this short wavelength, but atmosphere can absorb this long wavelength that is radiated by the earth, that is the terrestrial radiation. So the lower part of the atmosphere, the lower air of the atmosphere is heated due to the transfer of heat from the earth's surface. Okay, transfer of heat from the earth's surface to this atmosphere. Now you should know that the atmosphere is cool, the earth's surface is warm, so the heat is transferred from hot surface to the cold surface. Okay, from hot surface to the cold surface, and this is called as conduction. So conduction is the process in which the heat is transferred from the hot surface to the cold surface until they both reach the same temperature. Remember, conduction is the process in which the heat is transferred from the hot surface to the cold surface, and the transfer goes on till they reach at the same temperature, and this is called as the conduction. So the heat is transferred into the atmosphere from the earth's surface in the form of conduction. Okay, earth's surface is getting heated up and the heat is transferred to the atmosphere through the conduction. Now the lower surface of the atmosphere is getting heated up. But what about the upper surface, the upper layer of the atmosphere, the upper air of the atmosphere, that is here? Then how does the heat reach at this layers? So the heat reaches at this layer through the process of convection. Now convection is a process in which the lower part of the atmosphere which has got heated up, it expands. Now you should remember one thing, when the air is heated up, it expands. जब एयर का टेम्परेचर इंक्रीज होता है वो एक्सपैंड होती है, दैट मीन्स इट विल गेट लाइटर, और जब वो लाइट हो जाएगी, ओके, एट दैट टाइम इट विल राइज अप. सो द एयर विच इज गेटिंग हीटेड अप ड्यू टू द कॉन्टैक्ट ऑफ द terrestrial radiation, it will rise up. Why? Because it is getting lighter, it has expanded and it is going up. And now the upper air which is not heated up and it is heavy, that will submerge down. Why? Because this air will be heavy as compared to the heated air, and the cold air will go down, and in this way the cycle will go on. Okay, the air which is getting heated up, it rises up, and the cold air which is not heated up, it goes down. Why? Due to the wet. Remember, the heated air is lighter and the cold air is the heavier. These are the two important things you should remember, okay, because in further lessons when we study about the atmosphere or the weather system, that time this is going to help us. Atmosphere, see, remember, the hot air, it expands and it is lighter in the wet, and cold air, it is heavier in the wet. Okay, so here you will see the air which is heated up, it rises up, and the cold air, it goes down. So this gives rise to the cycles. Okay, and this is called as convection. Okay, convection, in which the air transfer is going on, the cycle is going on. नीचे से हवा गर्म हो रही है, ऊपर जा रही है, ऊपर जा करके वो जो ऊपर की हवा जो है वो नीचे आ रही है फिर से गर्म होने के लिए. ठीक है, तो ये एक साइकिल शुरू हो जा रही है, and this is called as convection. So this you can say as the vertical distribution of temperature. Okay, air is getting heated vertically. So what does this say? This says that the heat is transferred from the earth's surface to the upper layers of the atmosphere. This means the heat is transferred from earth's surface to the upper layers of the atmosphere, and this you can call as vertical distribution of heat. Distribution of heat. Okay, vertical distribution of heat through the convection. But what about the horizontal? What about the horizontal? So the same thing applies in the horizontal distribution also. How? Because for example here the transfer here, so in this way the heat will be distributed horizontally. Okay, and this is called as advection, that is the horizontal distribution of the heat. Okay, horizontal distribution of heat due to the advection. So these are the processes which are working in the distribution of the atmosphere, distribution of the heat, vertical as well as horizontal. Okay, so here the pictorial representation, if we see here, the sunlight is falling down, the earth's surface get heated, and the terrestrial radiation, which is of long wavelength, it heats up the atmosphere. Okay, and the convection goes on and the vertical distribution of heat takes place. And here the advection is going on, the atmospheric heat flow, which works in the horizontal distribution of the heat, that is the temperature. Now, what are the factors that are controlling the temperature distribution, that is the heat distribution? So firstly, you will see, now we have studied this in our previous lessons also, that latitude plays an important role. Why? Because we have seen that Earth has a tilted axis, and these are the latitudes. Okay, so as you go higher the latitudes, the temperature will go on decreasing. Okay, here it will be maximum, but as you go away from this 0-degree latitude, the temperature will go on decreasing. Okay, this is the 0-degree latitude, that is equator. And as you go away from the equator on both sides, the temperature will go on decreasing. Secondly, the altitude. Now altitude, as you go higher and higher, okay, the temperature will go on decreasing. Okay, with altitude also the temperature goes on decreasing. Now the distance from the sea. Now you should know two important things. Okay, and when we were studying about the various landforms also, that time also I told you that the heating of water as well as the land surface is very different. Land, it heats up quickly and it loses its heat also quickly, but water, it takes time to heat up, but it loses its heat very slowly. So due to this temperature difference in the sea as well as at the land surface, so in this case, in the daytime, here the sun rays are falling equally, right? In the sea also and on the land also. Okay, in the sea also and on the land also, the sun rays are falling equally, but the land, it gets heated up quickly, and the sea, it heats up slowly. So here when the land is heated, the pressure will be low. How? Because we have studied that when the land gets heated up, that is, the land gets heated up, that means the air around it will also get heated up, and when the air gets heated up, it expands, and when the air expands, the pressure will be low. Okay, why? Because the air has expanded. But at the sea or the waters, they heat slowly, that means the pressure will be high. Okay, so you should remember the air it blows from high pressure to low pressure. So here you will find the sea breezes coming towards the land, okay, and occupying this place, and due to this the temperature will be very normal. Why? Because the airs are blowing from the sea and cooling this area. Okay, so these are the land breezes and the sea breezes. Okay, why? Because land, it is getting heated up, sea, it is getting heated up very slowly. So land is warmer, it is heated up, the pressure, that is the air pressure, is very low. At the sea, the pressure is high. So the winds are blowing from high pressure to low pressure, and the area above the land, it is getting cooled down. Okay, so this is the reason you will find that on the coastal areas, the difference between the summers and winters is very less. Okay, but as you go away from the coastal area, that is, as you go away from the sea, like take example of India. In the southern region, that is in the Maharashtra or Karnataka or Andhra Pradesh or maybe Kerala or Tamil Nadu, so these areas are very close to sea. So they will experience less variation in the temperature during the summers and winters. But why? Because here the moderating effect of sea is taking place. The sea winds are blowing towards land and they are moderating the temperature of the land. Okay, the sea breezes are blowing and they are moderating the temperature over the land. But as you go in the north side, there you will find, for example, in Delhi is far away from the seas. Okay, and there are no sea breezes to moderate the temperature. So this is the reason you will find that the winters in Delhi are very harsh, as well as the summers in winters are as well as the summers in Delhi are also very harsh. So you will find the extremity. Okay, the winters are also extreme and the summers are also extreme. So you will find the extremities of the winter as well as summer in Delhi area or the northern area. Why? Because they are far away from the sea and there is no sea breeze to moderate the temperature. Okay, so this is the basic difference. So these are the factors which are controlling the temperature distribution. Then again, the air masses and ocean currents. So ocean currents are also very important. There are various ocean currents which flow in the oceans and they also act on the coastal regions. Okay, and they also determine the temperature and climate, the weather of the coastal areas. Okay, so we have two type of ocean currents. One is warm current and one is cold current. So there are two types of ocean currents, warm currents as well as cold currents. So these two type of currents, these also play an important role in controlling the temperature distribution. Okay, so this is all about this chapter, that is the solar radiation. Okay, now in our next chapter we are going to study about an important topic, and that is the weather system. Now you should remember here that whatever we have studied here, that is the convection, the advection, okay, and the moderating effect of the sea. So these all concepts are very important because these we are going to need when we study this next chapter, that is the next lesson, that is the weather system. This is the very important chapter, and to study this chapter your concepts in this lesson should be clear. So if you have confusion about any concept, you can revise the lesson and then only then you go to this chapter, that is the weather system. Okay, so this is all about the solar radiation. In our next chapter we will study the weather system. So stay tuned to us.